This is section 2.5, part 2 of this. The first part we did the intersection of inequalities, and now we're going to talk about the union. The solution set of a compound inequality formed by the word OR is the union of the solution sets of two inequalities. OR is represented with this symbol, and it means the union of graphs. When we're graphing these, we want to know what we will get when we put both graphs together. We're going to solve each inequality. So we have 5x is less than or equal to 13. Divide both sides by 5, and x is less than or equal to 13/5. Now as a decimal, I'm going to approximate that. 13 divided by 5 is about 2.6. X is greater than or equal to 4 on this side. So now we're ready to graph this. On the number line, 2.6 is going to come first, so it's here and here, 4. So I'm going to write x is less than or equal to 13/5. X is greater than or equal to 4. And this time our solution is going to be an OR, or union problem. So x is less than or equal to 13/5. This is now a bracket. We recall bracket is because of this equal to symbol right there, and it's less than, so we shade to the left. X is greater than or equal to 4 is going to be a bracket on the 4, and it's greater than, so we shade to the right. Now a union says, what do you get when you put both of these together? So if I include the blue part on my final graph, the blue portion, and I include the red portion on my final graph, the solution is going to be given, and the highlighted section represents the union of the two inequalities. Now to write that in interval notation, I'm going to start right here on my left in negative infinity and stop at 13/5. So that gives me negative infinity to 13/5, put a bracket, union, and I pick back up here and have to describe from 4 to positive infinity. So union, 4 is a bracket, and it goes on to positive infinity, which is always a parenthesis. Number 4, we're going to continue in the same manner, add 5 to both sides, solve these inequalities, divide both sides by a -2. We recall our rule. It says if we divide both sides by a negative, you have to flip this sign. X is greater than -1. Divide both sides by 6. X is less than 0. On the number line, -1 comes before the 0. X is greater than -1. Put your inequalities over here on our graph, and this is an OR. It's an intersection. To begin, we're going to graph x is greater than -1, so we go to the -1. It's a parenthesis, and we shade to the right. X is less than 0 is a parenthesis on 0, and less than means everything to the left on the number line. Our union, our OR, is going to say, what do you get if you were to put both of these graphs together? Well, if I include the red part, I'm here, and then the blue part picks up the rest of it. So we're going to shade our whole entire line for our OR, for our union. The solution graph, represented in inequality as an interval notation, is going to be negative infinity, and it shades all the way through to positive infinity. So the interval is negative infinity to positive infinity. Okay, this page is just going to try to help us sum things up. We're going to look at this graph in the middle. This is a graph, and I'm going to ask you the intersection, which intersection is and, what do these two have in common? And we would graph that. Interval notation of that answer would be -1, 1. The union of these two, of that same graph, is going to give us the interval notation -infinity to +infinity. So then we look at the second graph. I took this graph, I'm going to ask you the intersection. This is the answer to the intersection. And the union, this is the answer to the union. And once again on graph 3, the intersection over here is going to give us no solution. It's saying, what do these two have in common? And on this side, it's going to be the union. What do you get if you include both of the graphs together? And that's our union. So take a few minutes, look over these, and see if you can make those connections.